Hi, welcome to our software engineering tutorial series. We will be continuing with our second part of the video for the introduction to software engineering, its key concepts and challenges. So, the topic of this video is key concepts in software engineering. Let us now begin with the basic differences between the term software engineering and software programming. Discussing the scope first. Software engineering is a comprehensive discipline that covers the entire software development lifecycle, including key phases such as requirement analysis, design, implementation, testing, and maintenance. It emphasizes a structured approach to ensure that software is developed systematically and meets user needs effectively. In contrast, software programming focuses specifically on writing code, where programmers take designs and specifications and convert them into functional software. While software engineering manages the overall process, programming deals with the practical implementation of those plans. So both the fields have their importance. The importance of software engineering lies in its ability to deliver reliable, scalable, and maintainable software. It fosters team collaboration and structured workflows, which are crucial for producing high-quality software products. On the other hand, software programming is vital for transforming ideas into operational software, providing essential coding skills that are necessary for the development. However, both the fields have their drawbacks too. Software engineering requires a broader skill set, including project management and communication, which can be challenging for some teams. Additionally, the comprehensive approach can lead to longer timelines and higher upfront costs. Conversely, programming often focuses narrowly on coding, which may overlook the entire system architecture and project management aspects and can lead to integration issues later on. So, when it comes to cost, software engineering typically involves a significant initial investment. Still, this can result in lower long-term costs by minimizing risks and reducing maintenance needs. In contrast, software programming generally incurs lower initial expenses, but it may lead to higher long-term costs due to the need for extensive debugging and maintenance. The next important concept is managing teams, complexity, and longevity in software engineering. Beginning with working in teams. Teams of developers often work together on software projects. Methods like Agile and Scrum help improve teamwork by encouraging regular meetings and clearly defining each person's role. This way, everyone stays focused on the same goals and works together more effectively. Next is managing the complex software systems. Software engineering helps manage complexity by using modular design and design patterns. This approach makes it easier to understand, test, and fix software. By breaking the software into smaller parts, it reduces errors and enhances reliability, ensuring a smoother development process. The last one is long lifespan software systems. Many software application requires updates over the years to remain useful. Effective long-term maintenance practices includes keeping track of changes, documenting the code, and planning for future updates. These steps helps ensure that software remains functional and secure as user needs evolve. Let us now begin the topic software process and development. Let us discuss the scope of software engineering first. Software engineering covers many activities needed to create and maintain software systems. Let's look at the main parts in order. First, we start with requirements gathering. This is where developers talk to users to find out what they need from the software. Getting clear requirements is really important because it sets the stage for everything that follows. Next is specification. This means writing down the requirements clearly. This document helps everyone involved understand what the software is supposed to do. After that, we move to planning. In this phase, software engineers figure out how the project will be done. This outlines timeline, resource needed, and how to manage risks. The next step is design. Once we have the specifications, engineers create a blueprint of the software. This shows how different parts will be worked together and what technologies will be used. Following the design phase is implementation. This is where programmers write the actual code based on the design. It is important to write neat and clear code for easier maintenance later on. After coding, we move to integration. This phase combines all the pieces of the software to make sure they work together correctly. Integration is vital to ensure the whole system functions as intended. Finally, we have maintenance. Software needs regular updates to fix issues, improve performance, and add new features. Maintenance keeps the software useful and up to date. Let us now discuss the software development processes that are used in industries. The two broader categories for the development processes are plan-driven and agile processes. Let's discuss them. Plan-driven development is a traditional approach that emphasizes extensive planning and documentation before any coding begins. In this model, the entire project is defined at the outset, including the requirements, timelines, and budget. This method is particularly effective for large projects with stable requirements where the changes are less likely to occur. An example of a plan-driven process is waterfall model. In the waterfall approach, each phase must be completed sequentially. On the other hand, agile development is a flexible approach that focuses on being adaptable and collaborating with customers instead of sticking to the strict plans. In agile, team works in short cycles called sprints, tackling small and manageable parts of a project. The setup allows them to regularly check their progress and make changes based on the user's feedbacks and evolving needs. One popular agile method is Scrum, which includes the regular meetings known as Scrums, and to discuss what's been done and plan the next steps. Agile is specially used in fast-paced projects like mobile app development where users' requirements change quickly. Let us now move towards discussing the importance and drawbacks of the techniques used in software development. The first technique is waterfall model. One of the simplest development techniques, but its inflexibility makes it harder to adapt to changes, making it less suitable for evolving projects. The next technique is Agile. Agile prioritizes rapid application updates to quickly respond to user feedback and changing requirements, ensuring continuous improvement and adaptability. But constant small changes may not result in significant overall improvements, and it requires close coordination among developers to ensure consistency and alignment. The third technique is DevOps and CI/CD. DevOps stands for Development and Operations, while CI/CD stands for Continuous Integration and Continuous Delivery or Continuous Deployment. DevOps ensures continuous application updates throughout the entire lifecycle, improving collaboration and speeding up the delivery. A drawback of DevOps is that it often requires extensive communication and change management, which can complicate the process and slow down the implementation. So, as the techniques were discussed in the previous slide, we will now discuss the notations that are used to represent how the systems are designed. There are many of them, but the most common and standardized is the UML, Unified Modeling Language diagram. It uses diagrams like use case diagrams and class diagrams to represent the design. The next is Entity Relationship Diagram or ER diagram. It represents a system in a way that relationship between the objects as shown along with their defined attributes. The last one is Data Flow Diagrams or DFDs, which represents how the inputs are transformed into output through various processes and data stores. This marks the end of the second part of the video, that is key concepts in software engineering. We will discuss the costs and maintenance of software in our next video. Thank you so much for listening. We will be moving to the next video.